Hi all, this is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. So let us discuss definitions and terminology of unconventional machining process. So basically, in this topic, we need to discuss small answered questions so that these definitions will be useful to the students for the fast and quick review. Okay, so at the end of this session, student will be able to define unconventional machining process and various terminologies associated to this unconventional machining process. Okay, right. Now, what is the need for unconventional machining process? Okay, what is the need for unconventional machining process? High production rate, okay, low cost production, better surface integrity, high surface finish. Definitely high surface finish that we expect, and better surface integrity, no issue. But low cost production, here I think you may have doubt. Because of this expensive equipment, how can we expect low cost production? But because of the complexity of the geometry, the profiles cannot be cut by using the conventional methods. So thereby this technique can be deployed. Subsequently, we can expect the production with low cost. Okay. So if the complexity increases, it is very difficult to manage with the conventional methods, and it will take much time, and it will take much other precautions and setups too, so that the cost will be increasing. Okay, but here with this sophisticated technique, definitely we can machine even complex and brittle materials so that it can be low cost of production. Next, high production rates. So already in the previous presentations that we have come to know that the material removal will be less, but how can we expect high production rates? For regular profiles, it can be cut high machining or high material removal. Okay, so that high production rate that we can expect. This is also particularly for complex shapes, and if the material removal is very less, that means when we deal just to finish, okay, in terms of microns, this would be better. Okay, so usually we use these techniques for the sophisticated and high precision and high surface finishes required. Okay, right. What are the characteristics of UCM process? What is UCM? Ultra unconventional machining processes, UCM. Okay, not USM, UCM, sorry. Next, these are the different characteristics of unconventional machining process. Performance is independent of strength barrier. Use different kinds of energy in direct form. In general, low material removal but better quality products. Okay, comparatively high initial investment cost. Okay, so this is one of the advantages too. Okay, actually initial investment cost is high. Okay, but the thing is that if we deploy for the mass production and for the special jobs, this would be better in terms of economy. Okay, right. Tool material need not be harder than the workpiece material. Okay, so usually in order to machine, the workpiece material should be less stronger when compared to tool material, but it is not true in this case. Here the tool material can be soft in compared to the hard workpiece material. Okay, machine surface do not have any residual stresses. That is one of the greatest characteristics of the unconventional machining process. Why? Because here the localized stresses or the localized material removal will be taking place. Okay. Next, what is meant by conventional machining process? In conventional machining process, metal is removed by using some sort of tool which is harder than workpiece and is subjected to wear. In this process, tool and workpiece are direct contact with each other. Okay, so in conventional machining process, the tool and work are come in direct contact with each other. What is meant by unconventional machining process? The unconventional machining process do not employ a conventional traditional tool for metal removal. Okay, instead they directly utilize some form of energy for metal machining. Okay, in this process there is no direct physical contact between the tool and workpiece. Okay, so in unconventional machining, no direct contact between the tool and workpiece, but in conventional machining process, the direct contact will be there between tool and the workpiece. Right. List the conventional and unconventional machining process in terms of principles or distinguish between traditional and non-traditional machining process. Right. In conventional machining process, the material is removed in the form of chips by the advancing cutting tool that plastically deforms the material ahead. In the case of unconventional machining process, energy that may be electrical, chemical or thermoelectric and mechanical in its direct form is utilized for the material removal, and so there is no physical contact between the workpiece and tool. Okay, right. Right. Choose the various types of energy sources used in non-traditional machining techniques. Okay. Give examples for each or how non-traditional machining processes are classified. Okay. So pneumatic pressure, abrasive jet machining, hydraulic pressure, water jet machining, ultrasonic machining, abrasive water jet machining, corrosion, under corrosion, chemical machining, chemical bonding, photochemical milling. Okay, high current density in electrolytes, ECM, high voltage, EDM, first part, IBM, that means ion beam machining, electron beam machining, okay, that is ionizing, laser beam machining. Okay, so here creating avalanche in lasing medium, again PAM, means plasma arc machining for ionizing the plasma gases. Right. Identify the mechanisms of material removal, transfer media and energy source of EDM. EDM means electro discharge machining. Okay, mechanisms of material removal, fusion of material by arcs, transfer media, electron system, energy source and electrical spark. What is the mechanism of material removal, transfer media and energy source for ECM and ECC, electrochemical machining and electrochemical grinding? Right, here mechanism of material removal, ion displacement, transfer media, electrolyte, energy source, high current. Okay, so here the energy source is high current. Okay, and mechanism of material removal, ion displacement, transfer media, electrolyte. Okay, what is the mechanism of material removal, transfer media and energy source of EBM, electron beam machining? Mechanism of material removal, vaporization and transfer media, electron stream, energy source, high speed electrons. Okay, what is the mechanism of material removal, transfer media and energy source? Okay, material removal, vaporization, okay, transfer media, amplified coherent light and source of energy source, okay, powerful radiation. Okay, so here transfer media is amplified coherent light radiation and energy source is powerful radiation. Okay, What is the mechanism of material removal, transfer media, energy source of plasma arc machine? Okay, material removal, vaporization, and transfer media, ionized gas stream, and energy source is high voltage. Okay, right. List the mechanism of material removal, transfer media, and energy source for ultrasonic machining. For ultrasonic machining, mechanism of material removal is erosion, and transfer media is high velocity particles, and energy source is hydraulic pressure. List the mechanism of material removal, transfer media, and energy source of abrasive jet machine. Right. Mechanism of material removal, erosion, and transfer media is high velocity particles, and energy source is pneumatic pressure, maybe mechanical and fluid motion. List the mechanism of material removal, transfer media, and energy source for water jet machine. For material removal, erosion, transfer media, high velocity water jet, and energy sources pneumatic and hydraulic pressure. Okay, list the energy source applied in the following process. Okay, ion beam machining, chemical milling, electrochemical grinding, electrochemical machining, electro discharge machining, electron beam machining, abrasive jet machining, laser beam machining. Okay, right. Here the energy source we have to explain. Okay, right. For ion beam machining, ionized substance. Okay, for chemical milling, corrosive agent. For electrochemical grinding, electrical current and mechanical motion. For ECM, electrochemical machining, electrical current. EDM, electro discharge machining, electrical spark. EBM, electron beam machining, high speed electrons. AJM, abrasive jet machining, mechanical and fluid motion. LBM, laser beam machining, powerful radiation. Okay, so these are the energy sources for different unconventional machining processes. Okay, right. What is the necessity for unconventional machining processes, or what are the importance of unconventional machining, or enlist the requirement that demands the use of advanced machining process. Okay, right. So far we have discussed that with conventional techniques we can machine if the material is soft or ductile enough or malleable enough. But if the material is hard and brittle, it is very difficult to cut or machine with the traditional machining process. And at the same time, the geometry is complex. Definitely, in conventional methods, it will take much time and it requires many other setups too. And at the same time, we cannot expect high precision. Okay, and definitely, unconventional machining processes overcome these difficulties. That's what we have so far discussed. So here, what is the necessity for unconventional machining process, or what are the importance of unconventional machining? That's what we have discussed. If the material is strong, hard, there we have to go with unconventional machining process. Now let us look at here. A hard and difficult to machine materials such as carbides, stainless steel, nitralloy, hastelloy, and many other high strength temperature resistant alloys find wide application in aerospace and nuclear engineering industries. Many of these materials also find applications in other industries. Owing to their high strength to weight ratio, hardness, and heat resisting qualities, we are using this unconventional machining setup or system. Okay, right. Define unconventional machining according to major energy source employed. Okay, define unconventional machining according to major energy source employed. Unconventional machining are classified according to major energy source as follows. Okay, A. Thermal energy methods. Okay, in this method, heat energy is concentrated on a small area of the workpiece to melt the vaporized tiny bits of work material. Okay. Examples: laser beam machining, plasma arc machining, electron beam machining, ion beam. Okay, so this is answer, not AP. Next, name the unconventional machining process which are: 1. Use it to remove maximum material. 2. Use it to remove minimum material. 3. Consumes maximum power. 4. Consumes minimum power. Okay. So for different things, we are having different techniques. Use it to remove maximum material. We go with electrochemical machining, plasma arc machining. Okay. Use it to remove minimum material, electron beam machining. Consume maximum power, laser beam machining. Okay, laser beam machining requires maximum power. Consumes minimum power, plasma arc machining. Here the power requirement is low. Okay, right. Name the unconventional machining process for machining following materials: non-metals like ceramics, plastics and glass. Second, refractories. Third, titanium. Fourth, superalloys. Fifth, steel. Okay, right. For non-metals like ceramics, plastics, and glass, ultrasonic machining, abrasive jet machining, electron beam machining, laser beam machining are best suited. For refractories, okay, ultrasonic machining, abrasive jet machining, electron beam machining, and electro discharge machining. Okay, and for titanium, okay, for titanium, electro discharge machining is good. Okay, titanium is having high strength to weight ratio and hard. Superalloys, abrasive jet machining, electrochemical machining, electro discharge machining, and plasma arc machining. For steel, electrochemical machining, chemical milling, electro discharge machining, and plasma arc machining are best suited. Right. Name the unconventional machining process which produce best surface finish. Okay. Abrasive jet machining is the first one. Electrochemical grinding, electrochemical deburring, ultrasonic machining. Okay, so for best surface finish, these four are very popular. So these are the references associated to this presentation. So with this, I'm concluding. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.